videos that you've had so far. By the way, were there any questions on the video before I start doing the little review from last night? Any questions? Okay, so here's a quick review. And the quick review starts with this.
Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, bass. Yeah, it's pretty clear, I ain't no science fool. So you got litmus, well I can turn it blue. Make it go boom boom all over the place. When all the H plus meet all the OHs. Pink phenolphthalein, I think that's straight dope. Mix in a lipid here and it'll make it soap. You want it neutral, pH is low. Better set up a titration with a strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. If an acid gets in, then we just have to neutralize. You'll know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, Ha! I'm gonna do the math to figure out the ratios to react. Stoichiometry, yeah, that's where it's at. And it'll tell you to prepare at least 1 molar for your strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. Cause if acid gets in, we can fix it with alkali. You know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass,
This will be up on the
Hey, musical scientists.
Okay, so really quick review. Acids are sour, so they are like what? What are some of the things you tested? Apples, oranges, sour. So like lemons. Okay, bases are bitter. What would they be like? What did you test that they... You ever had to say something, a bad word, your mom washed your mouth out with soap? It's soap. Bitter is soap. Okay? So, strong acids and bases. What does strong mean? This is a review. Quick review. What does strong mean?
No,
not concentration.
Means, with the 100% ion.
Right. It means it's 100% ionized, meaning when it hits water, it splits to its ions. Okay, 100% it goes to its ions. So if that means strong, what's weak?
0%.
Or a very small amount, 1 to 5% ionized, right? Okay, so we remember our strong acids. You got to have these memorized or get them on your card. You got your oxyacids are the first 3. The H2SO4, only the first hydrogen coming off is considered a strong acid. The second one is considered weak. Okay, so oxyacids, binary acids, there's our 6. Our strong bases, remember they were in the tetras pattern, and that includes sometimes rubidium and cesium, even though we don't list them here, and it actually makes a B on the left-hand side of the periodic table. It's just we don't use them because they're not there very much. It's on the video. Okay. All right, so this is just a quick review. The first thing we talked about was Arrhenius. Arrhenius has, as a definition, H plus is an acid donor and bases are an OH donor. Going out a little bit from that, we got Bronsted-Lowry, and Bronsted-Lowry says that acids are a proton donor and bases are a proton acceptor. One more out from that, we get Lewis, and Lewis is all about the Lewis dot, all about electrons, and an acid is an electron pair acceptor this time, not a donor, and a base is the electron pair donor, so it's flipped for that outer one. Okay? You should have gone over and over. Acids are under 7, bases are above 7. 7 is neutral, and you always have H plus and OH. When we did our POGL, our pH POGL, you should have seen that even though a solution was basic, we still had some acid in there. Okay, the larger the concentration determines which the solution is. Is it acid or is it base? You also should have been testing lots of different substances, right? What did you find most of the substances were that you tested at home? Were they acid? Were they base? I don't know. I haven't tested them yet. They're mostly acid. If you look up here, most of the stuff that you eat is in the acid range. I'm not sure that you would eat detergent or ammonia. You might eat some milk and magnesia if your tummy's upset. Okay, those are bases. Okay, we have some important equations that we need to make sure that we memorize or have on our card. An easy way to remember it is anytime you have a P in front of something, it's going to mean minus the log of whatever I have concentration-wise. So minus the log of it. If I have a concentration that I'm trying to find, then it's going to be 10 to the minus P of whatever I'm trying to find the concentration of. Then the other two that are connected here are the pH and the Kw. If I take pH plus POH, I get 14. Well, if I take the concentration of hydrogen times the concentration of hydroxide, I get 10 to the minus 14. Well, how do I get that? I add the exponents of those. Okay? Those are all on your square that I gave you, that little square that has all the things that looks like this. Okay? All those equations are on there, so you can go from one thing to another. Yes? You don't have that. There's some in the CE. Okay, so you need to be able to go back and forth, and this little square that I made for you sort of helps you. If you want to use it on the test, you have to put it on smaller on your card. Okay? Is anybody having problems calculating back and forth? I have some example problems here I can do with you, but if you're having no problems, then we can move on. Let's do them. Okay, so if I'm trying to find pH and I have concentration of hydrogen, then I'm going to take and follow this equation right here. Because I look on my square and I find what equations between those two things I'm trying to get to, and it's just this one. So I would go pH is equal to minus the log of 3.568 times 10 to the minus third. That was your take-home lab. If you, okay, yeah, you get anything that you don't have? Huh? Yeah, it was.
Will you get 2 more, please?
All right, so throwing that through a calculator, and you're definitely going to need a calculator. If you don't have one, there's some over by the flag. Okay, the clue here is when I minus the log of something, I look at the exponent on the 10, and it should be 1 less over here, unless this number in front of the times 10 to the whatever is a 1. If it's a 1, then it will be that exponent number. So it'll be 1 less, and I always go 2 after the decimal. So throw that in, and let's see what 2 point what it's supposed to be. 2. or 5. That's one other thing we did that day. So anything in there you don't have, that's what you need. So this is our answer as far as pH. Acid or base? Acid. Below 7 is acid. Okay. Then if I have this next one where I take the pH has been given to me and I'm trying to find the hydrogen concentration, on this one I'm going to use this equation. Okay? So I'm going to say concentration of hydrogen is equal to 10 to the minus pH, which is 5.8, and I'm going to get an answer. Your calculator will give you an answer of some number, E, some number. That E means times 10 to some power, and it will be negative. And this is a concentration, so we need to label it molar. 1.58 times 10 to the minus 6. Now, I could have guessed that from here because remember up here we looked at this and I told you it's going to be one less. Well, if I look here, it should be one more. Does that make sense? Okay, so this is my concentration of hydrogen. So let's do it for hydroxide. What if I had to do a hydroxide? So I've got, to find POH, I've got hydroxide given. And now I'm trying to find the POH. So anytime I P something, it's going to go minus the log. So POH, is equal to minus the log of 2.79 times 10 to the negative 6. So before we put it in a calculator, what's the first number going to be? 5. So I'm going to go 5 point something. So if I put it in my calculator and I don't get 5 point something, I know I screwed up in my calculator. Okay? So it's sort of a check. So go ahead and throw that in. Let's see what we get. 5.55 is correct. So that is my POH. Now, what is the concentration of hydroxide here if my POH is this? So again, I'm going to go to this equation right here now, and I'm just going to 10 to the minus POH. I should be able to say right away times 10 to the negative what? Because this POH I should actually put in 1.25. What should my negative be to? 2. And it's going to be a capital M. So now plug that through and see what you get.
Why is it to the negative? Put
10 raised to the negative 1.25.
Well, it's in that 0.056.
0.056. Why would my calculator say that? Because that's not in scientific notation. If I move it 1, 2, it's going to be in scientific notation, right? 5.6. And I should have one more. Was there one more number? 2. Yes, yes, that is correct. Okay, so what happens is we also have another equation that we did, which is just adding them together. And you'll notice on a pH scale, these are all going to add to 14. Okay, so if I have a pH of 4.5, what's the POH of 4.5? What's the pH? How do I get it? Good, 14 minus 4.5, and that's going to give me 9.5. Done. Okay? But what happens if they don't give me the concentration that I want? I have to do more than one thing. Okay? So here we have OH minus, and we've got this concentration, and we got to find pH. So I'm going to have to do more than one step. So I find where OH is on my square, and I look at where pH is, and I've got to go through 2 steps to get there. The first step is going to be finding the POH. So if I go minus log of 6.78 times 10 to the minus 9, I'm going to get POH. What should the first number be? 8. So 8 point something. Throw it through. Now, if you're on a multiple choice test and they're asking you this, and there's choices, I can choose really quickly which one it is, right? Okay, 8.17. That is my POH. In order to get my pH, I'm going to have to take 14 minus that to get my pH, which will be what? 5.83. Good. Okay, now let's do this next one. Same kind of thing, but this time we're given H plus, and we're trying to find POH. So what do you think the first step's going to be? Same kind of step. I want to find the pH, right? Minus the log of the concentration. And I get what answer? It should be 3 point something. Okay, so plug that through your calculator. If you don't have one, please go get one because you're going to need one. Do you have an answer to it? This is a minus here if you didn't see that. There's a log button. 3.46. So now we're just going to take that 14 minus that, because this was pH and we want POH. And we get 10.54. Is that right? We're done. So you should get very familiar, be able to go back and forth very easy. Okay? If you know the minus the log, and if you know 10 to the minus pH or POH gives you the concentration, and you know pH plus POH equals 14, and if you times the concentration together, you get 10 to the minus 14, you can convert anywhere. Okay, so here's another one to help you.
Bronsted and Lowry had a theory which they came up with independently. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates.
I like this.
When litmus turns from red to blue, it indicates a change in solution from an acid to a base. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates. The pH scale lets you see the level of acidity. Above pH 7 is where bases go. pH 7's neutral with acids below. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates. The pH scale lets you see the level of acidity. The difference between an acid and a base is a base accepts a proton which an acid donates. The difference between an acid and a base is a base accepts a proton which an acid donates.
Okay, I know it's a little silly, but it gets in your head and you'll know Bronsted-Lowry. You'll be singing that, humming that tune on the test. Okay? All right, so what I want to do is go into Logger Pro. If you've got Logger Pro on your computer, I want you to go ahead and get into it right now because you're going to need to do these things that I'm going to do with you. We're doing it next time, but I'm showing you how to use this time so that next time hopefully it'll go smoother. Okay, so after you've been in lab, and we're going to be using a pH probe, and I'll show you how to use that next time, you're going to do events with entry with the easy data, and we've used easy data before, but this time we're going to use events with entry. So as you do your titration, it'll ask you to do 0.5, and then stop it and enter how much you've added, and it will record the pH. Once you've done that, we're still going to have to go into the calculator with the tail up here, and you're going to have to search for your calculator. So you say refresh the catalog. If it doesn't work, then you go to another one and you refresh the catalog. And you keep doing that until it finally gets it. Now, all the calculators that I had don't have data on them. But when it finally would come up, you would see, I'm going to write here, right in here in this section right here, you would see L1, L2. And so I got to that box by this up here, the calculator with the tell. Okay? You won't see it because you don't have a calculator attached to it. But, and we won't, this is what you will see because you don't have anything attached to it. When you finally get something attached, in this box right here, you'll see L1 through L10. You'll want to click on L1 and L2 and say OK. When you do that, it will bring your data up in here. I just typed in some data so we could see it. Sometimes when you type in your data or have your data, the graph doesn't show. Okay, so I've already done this with 7th period, so I've prettied it up a little bit. To get things on the graph, you just double click the graph and this screen comes up. In graphic options, you're going to label what test this is or what lab this is. And you'll probably do titration 1 or titration 2. You want to make sure it connects the points and you have point symbols. Then you want to go into axes options. A lot of times this auto scale here and here will say auto scale larger and your graph will be really small. So you have to go in and choose auto scale, which doesn't make sense because you think auto scale larger would make it bigger, but it doesn't. Okay, so just choose auto scale and then say done, and you should have something like this. But we need to know at what point that inflection point is between where we started and where it starts turning the other way. In order to do that, we need to use a little bit of calculus. Lucky for us, it's built into the program and we don't have to actually do it. So this is how you get to it. The first thing you need to do is you need to make your graph smaller. So remember, click right where that, you'll get a double-sided arrow and you can move that. I'm going to come over here to the computer so I can work a little bit easier with the computer. So you grab your mouse and you grab this and you just move sideways. Okay? You'll grab where your data table is and you'll increase that because we're going to add 2 columns. So I want you to practice. Just throw some numbers in. And we're going to just practice doing this. Okay, you got Ayana, Brooklyn, you got some numbers thrown in? So you can try this. Just throw some numbers in for the first and second column. Now remember to be able to label these, you just double click this and then you would put your labels in, your long label and your short label and say done. So NaOH, and then for the second one, I did pH. So go ahead and do that real quickly. And then what we want to do is we want to come up here to data. Okay, everybody following me? Got ready? And you want to go down to new calculated column because we don't want to have to do the calculations. We want the program to do it for us. So click on that and this comes up. The first thing we want to do is the first derivative. So I'm just going to put first derivative. And for the short name, I'm just going to go FD, short. Now I'm not done. I have to choose what I want it to do. So I need to go down to functions here and click on it. And then go up to calculus because this is a calculus function we want to use. And you'll see a whole bunch of things come out. The first derivative is just called derivative. So we're going to grab it and click derivative. Now I want to do the first derivative of the pH. So I'm going to click variables and I'm going to click pH. And I'm going to say done. Now I've added it here, but I also want to add it on my graph. So I'm going to click my graph, double click my graph, and underneath axes options, I can click first derivative. And then say done, and it will bring that in for me. Okay, is everybody up to me? Ty, where did I lose you?
We went to data. What happened after you hit the data table?
Okay, so we're going to do it again for second derivative, so everybody else stay with me. So do another new calculated column, and this one we're going to call second derivative. And we're going to short name it SD. And we're going to go into functions again. Is that where you lost me? Okay. Then you're going to pick calculus. Then you're going to go second derivative. And then you're going to choose variables. And you're going to choose pH. Yep. And then you're going to say done. Now, here's my variables there, but I need to add it to my graph. So I click on my graph, double click on my graph, and I come into axes options and I click on second derivative and say done. Now, the nice thing is, if I've done a really good job with my graph, I'm going to actually see a spike come up and down right here in the first derivative. But in the second derivative, where it crosses the x-axis right here, so I'm going to get a little mark so you can see, where it crosses the x-axis right here, that is my point of inflection. That's the point at which it turns from a negative slope to a positive slope. Or negative slope, I don't know how it works. Anyway, it's my point of inflection. So if I want to mark that, I can do just what I did. I can come up to the x equals, and I can come across, and I can put a mark right there, but I've got to skinny it up off the top of the graph, so I have to keep moving it back and forward till I get to the top of the graph and hope it stays there. And then I can go and print it. Okay, and I've got everything on one graph. Okay, do you think you can remember that? I just have to keep coming up off the graph at that point. If I want the line, I do x equals. But if I come off the graph at an angle, then it just follows where I'm going. But if I actually take and I'm coming off the graph right here, like this, you'll notice right here in this little box right here, it'll tell me exactly where I'm at. So I know how many milliliters I'm at, which on this one, since I don't have very many points on here, it picks the closest one. So you can see how it jumps from back and forth. But we will have a lot more points, so hopefully that won't be a problem. I know there's another way we can just follow the line, but I'm not sure right now, so I'll have to look that up. Okay, but we can estimate off the graph here that it's about 5.5 milliliters that my point of inflection is, and that would be my end point. Okay? We have any questions? Now we can close this out, and you can go ahead and do sapling. Okay, we'll do an exit quiz. I'll bring you together about 7 to 8, 10 after. Okay? Questions?